Okay, so we're going to have a quick look at the testing for catalysts reactions. So I have my test tube 1 here, as you should be able to see. Test tube 1, this is our hydrogen peroxide by itself. I actually got this from the pharmacy. You can buy it, they use it as a disinfectant, but it's a little bit too concentrated when you buy it from the pharmacy, so I've had to dilute it down a little bit to make a solution that is not quite so strong. As you can see, it's just a colourless solution. It's not doing anything exciting at the moment. It's not doing the reaction we talked about in the intro video. So we're going to trial some different catalysts in it, like it says in the sheet. So in our first trial, we are going to put in 1/4 of a spatula of our copper oxide, which we have here, which is our black powder. What I haven't done, I haven't put my 10 centimeters into test tube 2. So our hydrogen peroxide goes in. Nothing happening at the moment. And then let's add a 1/4 of a spatula. When we say 1/4 of a spatula, we mean about 1/4 of the spatula. And put it into test tube 2. And let's see if we can get anything happening. So we'll give it a bit of a shake. Let it settle a little bit. And you should hopefully see there's a few little bubbles forming, but not very many. Just a few, little bit of fizzing going on, but nothing exciting, nothing excessive. Okay, and as we know, we're in school, chemical waste. So let's pour away test tube 2. Make sure that everything goes in our chemical waste bottle to get rid of it. Okay, so 3 and 4 are the same chemical, but we're going to use slightly different amounts of them. We're going to use 1/4 of a spatula of manganese dioxide in the first one and 1/2 in 4. So just so we can get a comparison of whether putting in more catalyst makes the thing go faster or not. Manganese dioxide is the catalyst, the chemical catalyst we tend to use the most for decomposition of hydrogen peroxide, so this should give us the best results technically. So let's go for, so this is our manganese dioxide. It is a black powder, a lot like peroxide. And let's put our 1/4 of a spatula in tube 3. A little shake. And hopefully you can see and possibly hear the bubbles forming. And for 4, we're going to put in 1/2 spatula. And you should be able to tell there's no difference between the 1/2 spatula and the 1/4 of a spatula. They're both just fizzing that same amount. Now what you will see in the experiment later this week is the effect that the manganese dioxide can have on a much more concentrated solution of hydrogen peroxide. This is very dilute, I've had to dilute it down. So you should be able to see a much more vigorous reaction. So for number 5, we're going to use a natural catalyst, an enzyme. I'm going to get this enzyme from some bits of potato. So hopefully we should see this time when we drop in the enzymes acting on the hydrogen peroxide. So it's potato. And see if you can see any fizzing going on. It's very little fizzing. You can possibly just see underneath bubbles starting to form on the potato. And we should leave that one for a little bit so we can observe if any bigger bubbles form. So after about a minute or so, hopefully you can now see there's some bubbles coming up from our potato. There are some bubbles forming around the top as a foam. It's not a very fast catalyst, but it is slowly catalyzing our breakdown of our hydrogen peroxide. Okay, number 6, last catalyst test. Again, this is another biological catalyst. This one is liver from chicken in this case. Your liver is obviously the part of your body that does a lot of chemical processes, produces a lot of enzymes, so lots of enzymes in there. So we're going to pop our liver into chemicals. So here is our liver. Hook it down in. A shake, and hopefully you can see straight away that bubbles start forming very, very quickly. The liver has already changed colour from quite a dark, reddy, bloody coloured brown to a much paler brown, where it's reacting with the hydrogen peroxide to release oxygen gas. So much more effective catalyst in this than in the potato. See lots and lots of bubbling going on. And again, has to go into our chemical waste.